Hello everyone, welcome to the third RoboU session. Today is going to be about electrical basics. We are going to be starting in 5 minutes. Alright, we have about 30 seconds till we start. Please take this opportunity to grab some paper or a drink, whatever you like. We're actually going to be waiting another 5 minutes just in case some people are coming late. Alright, it's about that time to get started. As stated earlier, today's presentation will be about electrical basics. Our presenter will be Braden Brown, who is, well, lead electrical. Enjoy.
Hello everyone, I am Braden Brown. I'm the electrical director for this year's robotics team. I'm currently a sophomore, and I will be teaching you the electrical basics for this RoboU. So, what does electrical do? Well, the electrical team builds, organizes, and maintains the robot's electrical circuit. So, here are some tools that we use. We will often use crimpers, auto strippers, and electrical tape. Crimpers simply are used for a simple and convenient tool, Andersons. Andersons we'll be using a lot, and they are simply a easy way to connect wires together, and crimpers are essential to go and get those wires to attach to each other. Auto strippers simply auto strip wires. You pull down and it makes your life a lot easier by separating the rubber from the copper. And electrical tape is simply tape that we put around the exposed wires so we do not hurt ourselves or short circuit any wiring. This is the power distribution panel, but we call it the PDP. It is connected to the battery and can power 16 customizable components, half of which are larger and half of which are smaller. They use fuses. The smaller ones use 20 and 30 amp fuses, while the larger one uses 40 amp fuses. But what is a fuse? Well, a fuse is simply a small circuit breaker. Whenever a fuse is gaining more power than it can support, it will burn out and stop the circuit. This also powers the RoboRio, the VRM, the PCM, and the CAN, in addition to those components I had mentioned earlier. The circuit breaker and the battery. The circuit breaker is simply the same as the one in your house. This will protect against an overload if the robot has one of such. Not only this, but we can turn it off manually with that red button, so we can go and work on the robot without having to detach the battery. It's both convenient and for safety reasons. This is the RoboRio. It is the brain of the robot, and we put the programming in here. This controls the CAN, the robot safety light, servos, limit switches, and it's also connected to the radio. These are motor controllers. At the top right, that is a Victor, while below that is a Spark, and below that is a Talon. Those are the three types that you'll see most commonly. Now, the drivetrain is an example of what uses 40 amp slots. Now, motor controllers are directly used off of the PDP and are connected to motors. The drivetrain needs those 40 amp slots because it has to be more powerful than the usual components. This is the case because we need the most power to make our robot move faster and quicker. Now, these motor controllers use CAN to communicate with each other. CAN are those yellow and green wires, and they are set up in a closed loop. So then each and every motor controller can communicate with each other. Now, Sparks specifically can control brushless motors. This is important because brushless motors are typically stronger than brushed motors. This is the case because brushless motors have less friction, and less friction means more energy equals momentum. The voltage regulator module, also known as the VRM, steps down current. Now, this is important because the radio we use needs about 1 amp. Now, a voltage regulator module has two sections, 12 volt and 5 volt. Each of those sections are split up in 2 volt and 0.5 amps. Both are amps, I messed up there. Now, this is important because some electronics might need a lot of volts but less amps, or less amps and a lot of volts. So since it's really picky, we use this. Now you'll really only see the radio on this, but sometimes you might see some other items. Like a common one you might see would be the limelight, which is simply just a visual system for the robot, but they are quite expensive, so you might not see it commonly. The radio. The radio is how we communicate with our drive station. It uses Wi-Fi to do so. This dislikes blunt force and tight restraints, so we'll typically have to put it to a secure place near the ground, like the drivetrain. This is the pneumatic control module. We call it the PCM. It controls and powers the air compressor, it powers the pressure switch, and it powers and controls the pneumatic solenoid. Pneumatic solenoids are like metal muscles, but they're kind of little, not nearly as bendy as muscles. So they are quite hard to use, but they really fill up the gap that motors can't fill up, which is why we use them. And they are honestly indispensable when it comes to that. The pressure switch. The pressure switch works in tandem with the PCM to control the air compressor. It simply just measures the air compressor, and at one point, if there's too much pressure, it will complete a circuit, and then it informs the PCM to go and inform the RoboRio to stop everything of the expansion in the air compressor. This is the robot signal light, also known as the RSL, but we call it the safety light. Now, this helps to tell us when it's safe to approach. This helps in competitions and in the shop, like I said, so we can safely approach any robot. Now, when it's off, that means the robot is off and safe to approach. When it is on, that means the robot is disabled and safe to approach. When the RSL is blinking, that means the robot is on and enabled, meaning it is not safe to approach. This is a limit switch. Limit switches are pressure-based buttons. Now, it has to stay or exceed a certain pressure in order to activate. These are connected to the RoboRio, as mentioned before. Now, I've mentioned all these, but what does a typical circuit look like? Well, bluntly put it, it looks like this. But a more realistic way of seeing it would be Team 254, the Cheesy Poofs. Now, the Cheesy Poofs has everything that you would really want in a circuit, but of course this doesn't mean that this is exactly what a circuit would look like. Simply put, we have the RoboRio at the very bottom right here. This communicates to everything in the robot, and it gets power from the PDP. Now, they do not actually have a battery plugged in right now, as you can see here, but they have everything else just ready to go. The RoboRio, it has its CAN connected up to all of the motor controllers, which are connected to the motors. This is actually the drivetrain. They actually have a solenoid up top here, which is connected to the solenoid valves and the PCM and the air compressor. And they have the VRM connected to the radio, and then they have their fuses and their PDP as well. All the bells and whistles and everything you'd want in a circuit. That's all I have for you today. I have been Braden Brown. Thank you for using your time. Have a nice day. Goodbye. Bye.
That concludes electrical basis. Thank you all for coming, and for those who are interested in electrical. As per usual, we will be playing the safety video streamed on October 24th, and that will be the end of this RoboU session. Thank you for coming, and have a nice day.
All right, welcome everybody to the 2020 RoboHawks University. This is week 1. Today we're going to be going over safety. And here with us is Jacob Butler, who's going to be taking us through the presentation.
Yeah, hi, some of y'all know me, some of y'all might not. I'm an alumni on the team, and I did safety on my time on the team, so I'm going to be helping out with the safety PowerPoint today. So right now, we're just going to go over some of our general PPE guidelines and how that is going to affect us with COVID-19 going on. So it's important to note here that we don't have a full set of guidelines from the county yet. We're still working on all of that. So this is just our general setup and what we'll be doing. And you can go ahead and just put everything up on the slides then. So we have PPE that's required at all times, and this is again just for general shop, and then we're throwing in all the COVID-19 guidelines that we're setting up right now in there. So safety glasses at all times in the shop. Those have to be clear and see-through. You can't have any tinting in them at all. We have to be able to see your eyes. Closed-toed shoes are required at all times in case you're dropping anything. They don't have to be steel-toe. I would suggest something steel-toe just in case you roll something over your foot, you drop something on it, but closed-toed at least required at all times. Hearing protection is required on your person at all times and used when you're running loud equipment. Again, I would suggest using it when you run any type of equipment. You'll hear constantly people complain as life goes on, they lose their hearing and they'll blame it on being in the shop, being around loud machinery. So wear your hearing protection. And then obviously a mask will be required at all times in the shop. At no time will you be able to take off your mask. If you are in your car alone, that's probably the only time you can take your mask off. But if you are in the shop with other students, you have to have your mask on. When you're within 6 feet of another person, you need a face shield. So we're going to be getting close and working on the robot. We're going to be within 6 feet. So you're going to have a face mask for that. No jewelry of any kind is allowed. No rings, necklaces, earrings, any of that is allowed. Rings can get stuck in machinery and pull your fingers off. Your necklaces can get stuck in something spinning and pull off. No lanyards around your neck or anything like that. Long hair has to be tied back, preferably in a bun, not a ponytail. A ponytail can get caught in something. Baggy clothes, you got to keep rolled up. So your baggy sleeves, make sure you roll them up when you're using machinery because they can get caught in something.
Hey, Jacob, can we pause for just a second? We're having a little bit of technical difficulty because there's music that's showing up that we're not sure about. Yeah, you can go ahead.
Can we still hear the music or no?
It's all good. Everything's good.
Awesome. Gotta love it. Okay, so yeah, hoodie drawstrings need to be tied up or tucked in because those can get caught in machinery and get yanked out too. And then that is our general PPE requirements. So next, we're going to be going over how we're going to be handling injuries in the shop. So any injury to any team member must be recorded via an injury report form. These are in our binders. Your safety captain knows where that is. Mentors should know where that is too. You need to make a mentor aware of any and all injuries, no matter how minor. So even if it's a small cut can turn into something worse if it's not corrected. So all the recorded injuries will be used to improve the safety culture of the team. So we're going to use them to make changes and improve. And then our goal should be to have 0 injuries. Obviously, that's ideal, but that's what we're going to try and do. And again, before we move on, I think it's important to note, again, we don't have our full COVID-19 guidelines, but in addition to anything we show you and teach you today, there's going to be precautions made in place for that. So things are going to be kept clean. People are going to be following the social distancing guidelines. We're going to be doing whatever the county tells us to do. But today is just a general safety, what you need to know for a regular season to keep yourself safe around tools and machinery. Okay, so now we're just going to go over some general shop safety. We're not going to go into anything super, super in-depth in the general, but just some stuff to keep you safe that you need to know about. So it's important to note safety is everybody's job. So it's not just it's not just the safety captain's job. It's not just the mentor's job. Everybody has to be aware of safety. Safety isn't a priority. Priorities can change. Safety is a condition of being in the shop. It's something that goes on always. So everyone needs to consider themselves and others whenever you do anything in the shop. When you're running a piece of machinery, when someone's running on a piece of machinery, when someone's working on something, you need to be aware of what's going on and respect other people that are in your area. Make sure that everybody's following the rules. We're not asking you to be a dictator and start going around and checking everybody and making sure they're doing what's right. But if you see someone start a machine and they don't have any safety glasses on, or if you see somebody about to like lift something or move something unsafe, make sure you say something. And you can do that respectfully. You don't have to be disrespectful, but it's just important to make sure that everyone's looking out for each other and we're creating a safe environment for everybody. So just a little bit about shop equipment here. So if you haven't used a piece of equipment before, or you need a refresher, you got to be accompanied and taught by a mentor. So if you go, hey, I don't know how to use a bandsaw, I've never used a bandsaw, get a mentor and they'll teach you how to do that. So again, one thing that we plan to do, we're going over safety today, but what's super important is actually being in front of the machine and seeing it used and then using it yourself so you understand how to operate the equipment safely. And that's something, once we have all the guidelines and once we figure out what's going on this season with in person, we will get that done. That's going to happen. But if you don't know, or if you say, hey, I know we've been taught on this, but I don't really feel comfortable, can I have help? 100% mentors are there for that. No one expects you to know how to use every piece of machinery. No one expects you to know how to use it for life. But if you need help with it, there's going to be someone there who can help you. So every machine has its own set of rules for safety and housekeeping. Things need to be cleaned off before and after use. Everything needs to be, done in a safe manner, and not every machine is run the same way. So you need to make sure you know what the safety guidelines are for each machine. Make sure your work area is clean before and after using the machine, or before and after working on anything. You don't want to set down a part on the top of a dirty area and start working on it. You don't want to run a machine that has a bunch of scraps in the way or anything. You want to make sure your work area is safe. When you're cutting material, like on a drill press or a bandsaw, excess waste that comes off of that is often really sharp. So metal shavings, sometimes even pieces of wood can splinter. You need to make sure that you're not grabbing that, that's not getting flung anywhere. Make sure that it's getting cleaned off with a brush. You don't ever want to use air to spray anything off. That's dangerous. It can put dust up in the air. All right, and we're moving on to hand tools. So it's important that you are using the right tool for the right job. A screwdriver is not a hammer. A wrench is not a hammer. Do not use it like a hammer. That's improper use and can cause damage to the tool and could possibly cause a tool to break and hurt somebody. You also don't want to use broken or damaged tools. So if you see a tool and you go, hey, this piece is kind of loose, this doesn't look right, the end of this is mushroomed, it's straight up broken here, do not use it. Tell a mentor when you see a tool in bad condition, or if you're unsure of its condition. If you go, hey, I don't know if should be like this. Is this right? Ask a mentor and they'll help you out. Be aware of where your hands are when you're working. I know that sounds kind of silly, but if you're holding something in one hand and using a screwdriver in the other hand to screw something into that piece, make sure that you're not applying so much pressure that you slip and stab your hand with the screwdriver, things like that. When you're drilling, make sure your hand is in the right spot. When you're putting a screw through something, make sure there's like no hand or piece of material on the other side. Make sure you put tools back where you find them. That's a big issue in the shop, is keeping things orderly. Make sure the screwdriver is going in the bin marked screwdriver. If we need a screwdriver for something, or we need a tool to pull something apart, we want to make sure we have access to it and know where it is. So, and don't leave the tools out unless you intend to use them. Obviously, if you're working on something for a period of time, you can keep the set of Allen wrenches out, next to you. But if you're done with that, try and put it back. Keeping stuff out isn't really smart. It gets in the way. We lose things. Just make sure you put things back where you find them, and treat the shop and the tools in the shop better than you would treat your own. It's important that we leave the shop better than when we found it. It's important to leave the tools in a better condition than when we found them. All right, battery safety. This is really important because obviously all of our robots are going to be using a battery. They're really more dangerous than you think, and it's important to keep them safe. When you're moving and carrying the batteries, always use two hands, never hold them with one hand. They weigh a lot, and you want to make sure you get a good grip on them. I normally put one hand on the side, one hand underneath. put both hands on both sides, whatever works best for you, but never hold them by the wires. You're just going to rip connections off, and that's a problem. Never fun for anybody. The batteries normally have a protector that goes in the in connector. It's just a plastic piece that sticks in so that nothing can get into the connector. If there is a battery that isn't connected, it needs to have one of those connectors in it. The only time that there's even a slight exception for that is a battery that's in the robot and has been disconnected for some purpose. If there are batteries on the side somewhere, if there are batteries and a charger that aren't plugged in, they need to have those connectors in there. If a battery is broken for any reason, you need to let a mentor or safety captain know. The safety captain will notify a mentor. It's not anybody's job specifically to clean up that battery spill. We want to leave that to a mentor. The safety captain will be trained on how to do that. And we have a battery spill kit located in the tool cabinet. So it's just an acid, and you want to neutralize the acid and then sweep that up. You need to use the right kind of gloves. It's something it's like putting out a fire. Not everyone is expected to use the fire extinguisher, to use the battery spill kit, but you need to know where it is, and there needs to be a person designated who's going to use it. All right, and next, moving and lifting. So this might seem kind of silly, but it's really important that when you are taking something from one side of the shop to the other, or you're moving anything around, that you're doing it in a safe manner. So you really want to plan your path from A to B. It's like, okay, we're moving these boards from, the garage doors in the shop to the area where we're working. We need to make sure that, there's not stools and stuff in our way. No one's going to trip on the way. There's not cords and like material laying on the floor that we're going to trip over. Make sure that when you are moving a large object, you are aware of where people are and where that object is, the geometry of that object. So I'm sure you've seen cartoons before where someone's holding something over their shoulder and they turn and whip around and knock somebody over the head or knock somebody over. We don't want anyone doing that. Make sure that you're aware of what you're holding, where you're moving it. When you're lifting heavy objects like the robot, you want to make sure you're lifting it with 2 hands and you're lifting them with your legs and not your back. I know, that sounds like something you'd say to an old person, but you really want to make sure you're lifting with your legs and not your back. You can cause serious injury that way, and it's just how you should train your body to lift these things. It's the best way to do it. Okay, now we're moving on to machine safety. So this is for the specific machines in the shop. And I want to say again, this is not a substitute for actually sitting in front of the machine and running it and being taught how to run it in person. Again, we're going to try and do that as best we can with the guidelines. And if we have people working in the shop, we're going to be training them how to use the machinery safely. So just take that into consideration when you're looking at all this. These are just general safety guidelines for the machines that we use, but there is, more to using the machine. So this will teach you how to use the machine safely in a safe manner, but again, it is not, in place for actually running the machine in person. So first up is the drill press. When you're running the drill press, you want to make sure that the material that you're trying to cut is clamped to the table. There's also a little vise on one of our drill presses in the shop, so whatever you need to drill through needs to be clamped to that. Most of the time, when you're trying to hold a piece there and you drill into it, it's gonna spin. You need it clamped down because the drill bit is gonna bite into it and immediately try and spin the work instead of cut through it. So we generally use scrap wood underneath the piece that you're cutting so that you don't cut through the table. The drill press is designed to the table have a hole in it and the drill press goes through that, but sometimes the table is moved or it's not set up accurately or there's other stuff in the way like the vise that's there, and you want to make sure that you are not drilling through the table or drilling through any equipment that's used to clamp your piece of material to the table. Make sure you remove any scraps that are on there with a brush and not by hand. So for example, if you're cutting through a piece of aluminum, normally there'll be aluminum scraps. You want to brush that away and clean the surface instead of scraping over it with your hand so that those flakes don't get stuck into your hand. It's the same thing with wood. It'll probably be small, like pieces of wood, but they won't really splinter, but every once in a while you'll get splintery wood in there, and you really don't want to clear that with your hand. You want to make sure you're cutting at the right speed. So for some material, you want to cut at a different speed. Uh, that that's more specific to again the bit you're using and the material you're cutting through. And you want to make sure you're doing that so that you're not cutting super slow through a piece of material, it could be dangerous. And you never want to slam the press down. You don't need to go inchingly slow, but you don't want to slam the press into the material and go at hyper speed when you're drilling through it. And you want to make sure you wait for this machine to stop spinning before you reach and try and clear out any material. Also, I believe one of the drill presses in the shop actually has a slow release to it. So when you release the handle, it goes up slowly, sort of like closing a door. It's critically damped so that it's not just going to fly all the way back up. But not all of them are like that. So we make sure when you're releasing that handle that it goes up slowly and doesn't slam into place. You want to also make sure that before you use a bit in the machine, that bit isn't broken or damaged. That could, cause the bit to crack when you're cutting through material and launch shards everywhere. And you also want to make sure any guards that we have are in place when you're using the machine. Bandsaw is a piece of machinery in our shop that gets a lot of use out of it. So it's really important that you're operating this machine safely, and you respect it and respect people who are using the machine. So the blade guard is the piece that covers the blade and it sort of holds the blade in place and keeps it from wobbling. So the bandsaw is a continuous loop of cutting blade that's in that machine, and you if it's not held in place properly, it will flex and bend. So you want to make sure that you're using the least amount of bend and flex as possible to be making sure that you're not going to flex that blade in a way that it's going to break. So the height of that blade guard needs to be 1/4 of an inch above the material that you're cutting, and it needs to be locked in place. Normally there is a turnkey on one of the sides of the bandsaw, and that needs to be locked in place so that it doesn't move up or down. You want to keep your hands as far from the cut as possible, and you never want to cut small material. And what I mean by small material, I don't mean thin material. I mean a piece that is very small. So if you have a square piece of wood that is 1 inch by 1 inch, you really don't want to be cutting that or anything smaller than that on the bandsaw. That's super dangerous. Your hands are really close to the cut. It could pull you in, and that's just not ideal. You want to use the proper guards when necessary. So sometimes you can attach a guard on the side that will keep your piece straight and you can just push it through, and that reduces the amount of hands that you have to have in the scenario. So you want to make sure that you're using those when necessary. When you're cutting something circular or rounded, so for example, if you have a parabolic curve that you have marked on a piece of wood and you want to cut that out, make sure you make relief cuts. And relief cuts are straight cuts that go into the edge of the curve, and then you're cutting out essentially tiny pieces of material instead of one long curve. So they're sort of lines that would normally be not tangent to the curve, but straight against the curve of the side of a semicircle. And then you're cutting through all of those instead of just one line of the semicircle. If you ever need to stop cutting, so let's say you're cutting a straight line into a piece and you decide, oh, I need to stop and then cut through the other side. Make sure the material stays where it is in the cut. You turn the machine off, keeping the material in the same place, wait till the blade stops, and then you can back it off from the blade. Never back a piece of material off of the blade while it's running. It's super dangerous. You risk breaking the blade, you risk messing up your material. It's just not a good thing to do. You also don't want to use excessive force. Don't slam stuff into the saw blade. That's dangerous. You don't need to be, pushing anything through at hyperspeed. It's going to cut. Don't be super slow either as to just sit there and burn material like wood. But again, you don't need to be flying through stuff. Just go with the cutting speed. You'll be able to feel it when you use the machine. And again, remove any scraps with a brush and not by hand. All right, next is the table saw. So the table saw is a really useful piece of machinery that, again, gets a lot of use, especially when we're making field elements. So you want to make sure that all guards are in place before you start the machine. Our table saws have a guard, it's like a clear plastic guard that goes over the top of the saw blade so that the saw blade is never out in the open while it's cutting. That is really important to have in place. It'll slide out of the way when you move stuff through it. It needs to be on there. You want to make sure your blade height is roughly 1/8 of an inch above your material, or about one sawtooth height above your material. So what you'll do, let's say you're cutting a piece of wood, you'll slide your piece of wood up against the saw, You'll turn the knob on the table saw until you see the blade rise about 1/8 of an inch or 1/2 of height above that material, and then you'll keep it there in that place. And you can lift the guard up for this reason, and then you have to lower the guard back down when you do that. You want to make sure you keep your material absolutely as flat as you can against the table to avoid kickback. So what kickback is, when you're pushing a piece of wood into the saw or piece of material into the saw, and it's not level on the table, the saw is spinning so fast and has so much grip that it is just going to grab that piece and launch it right back at you. If you're cutting through and the saw is actually making it all the way through the material, you're keeping it flat and you're pushing it straight, that shouldn't happen. You should never get kickback. But if your material is riding up onto the saw, it's almost always going to kick back. You want to make sure you're using the right guards for the right job. So there's guards in place for ripping and cross-cutting. So you need to make sure you're using the right one. In this picture here, in the bottom right, it's kind of on the text a little bit, but you can see that there's a guard on the side there. That guard locks in place and allows you to make a straight cut. And again, that's keeping you from holding your hand in that one spot. You also want to make sure, again, the material is flat against the guard and is in place. So the guard is useless if you're not actually pressing the piece of material up against that guard. Also, push sticks are one thing that we use to keep your hand away from the blade. It's essentially just like a wooden or a plastic stick that pushes down on the board, and you can use it to push through the blade. So it keeps your hand away. If you have a lot of material in between the guard and the blade, you can use your hand. But when you have less than probably 6 inches of material, I'd suggest using a push stick. And the table saw is arguably one of the most dangerous machines in the shop. It can cause kickback. The blade is spinning very fast. It's exposed. You want to make sure you are treating it with the respect it deserves. You need to make sure all the guards are in place. You need to make sure that you have people, standing away from the machinery when you're using it. You make sure your hands are moving in the right spot. Your material is flat. Just treat the machine with respect. You don't need to be afraid of it, but just know that it is a dangerous machine. So in our shop, we have 2 chop saws. We have one that we use in the wood shop for wood, and then we have one in the main shop that we cut metal and material like that on. So they're both fairly loud, but the metal one specifically is extremely loud. So when you're running the metal chop saw, ear protection is required for you, and let people in the area know that you're running it. It's very loud. It's jarring when you hear it go off. So make sure that you're saying, hey, I'm going to go run this. I'm going to go cut a piece of material on this. Use ear protection, and just be courteous to people around you. It's also important to note here, just as a general requirement when using any of the machines in the shop, make sure that when you're using the machine, that's what you're focused on. If you see someone using a machine, don't call their name, don't scream at them, don't horseplay. It's very serious. Someone can turn away, and then the next thing you know, they're cutting something they're not meant to be cutting. So any material that you cut in the chop saws, you need to make sure it's clamped down and it's tight. You need to make sure it's in the clamp, and then you can check to line it up with the saw and then lock it in place in the clamp. So the metal chop saw has a sort of sliding clamp on it, or vise, and you can use that. And the woodworking chop saw has a clamp that comes from the side and wraps around and locks down onto your piece of material. So you want to make sure there are any cords or fingers or anything out of the cutting path of the blade besides what you want to be cutting. So make sure that, again, the cord of the saw isn't draped over the cutting area. I know that sounds silly, but it happens. You want to make sure, again, your hands are out of that cutting space. So normally chop saws, like I know the wood one below, the Walt, I think there's some other brands that have it too. They actually have spots where they'll show you on the saw to place your hands. And the best idea is place it as far away from the cutting area as you possibly can. But yeah, you want to start the saw at the top of its arc. So they lock in that position at the top. And normally there are buttons on the handle that are like, there's a safety and then there's a start button on that saw. And you want to start it at the top when the guard is fully engaged. So if you see in that picture there on the bottom right, the guard covering the saw is fully engaged, and that's when you want to start it. You never want to start the saw with the blade exposed. So you start the saw on the top of that arc and you pull it down into your work, and you cut slowly, applying pressure as you move through. So you'll feel it catching the material and you'll cut right through. Blade's spinning fast, so it should cut through easily. The metal one is a little bit different. It feels totally different, and depending on what you're cutting, it'll slide through. So you want to, once you make that full cut and you come to the bottom of the arc, when you're done cutting, you want to release the safety and the power button. The saw is slowly going to spin down and stop spinning. And then once it stops spinning, you're going to release it, pull it back up to the top of the arc, and then remove any material. You never want to reach in when the saw is still spinning, even if it's like cut off, it can still cut you. And the last thing we're going to worry about is the lathe. So most, if not all, injuries from the lathe come from entanglement. That means that there's hair hanging down, there's something like baggy clothes getting in the way, someone's hand gets in the machine. The lathe is spinning at a very fast speed. It's spinning very accurately, so you need to keep loose items away from the machine and tied up, even if you were nearby. Even if you're not the operator of the machine, if you're near the lathe, make sure that nothing is hanging down from what you're working on near the lathe. The lathe is a really special piece of equipment. It's very unique, and it's going to be used by designated students. So obviously, if you want to use the lathe, if you want to learn how to use it, someone can teach you how to use that. But it's not really a machine that we want everybody standing in front of and working on. It takes practice, and it's very specific how you need to use it. So we ask again that if you want to use that machine, that you ask somebody or you're someone that's trained on it. You want to keep the working area of the lathe free of scraps and tools. Tools can get in the way when it's spinning and get launched out of it. You really want to keep that machine clean, and the students that use it take good care of it and try and keep it that way. Make sure the machine is off before you mount or remove any accessories or material. So again, it's spinning very fast. You don't want to be attaching anything while it's spinning. That's a horrible idea. You don't want to be inserting any material while it's spinning. That's a horrible idea. And we also have a CNC machine in the shop, and that's sort of like the lathe as a specialized piece of equipment. And that's something that you can get trained on, but it's not really something that any student can just walk up to and use any time of the day once they've been trained on it, like the bandsaw. Like the bandsaw, if you're trained on it and students have to go cut something on that. But the lathe and the CNC are different. All right, does anyone have any questions they want to type in the chat that I can answer?
Alright, that concludes this RoboU. Thank you all for coming, and I hope you guys have a great day.